Okay, so today you guys are going to learn how to find the equation of a tangent line to a curve. And in order to do this, you're going to have to be able to find the derivative, which is why you've been learning to find it. So on the screen, you can see I have a parabola, and there's a point on the parabola, all right? And if I slide the slider, you can see that the point moves, right? So if I know what the x value is, I can find out what the y value is by plugging it into the original function, right? An infinite number of ordered pairs. Okay, now, if I click this, I will get the tangent line to that parabola. And as I slide the point, you can see that the tangent line changes, right? The tangent line varies, right? Sometimes it, like over here, it has a negative slope, right? Right here where the slope is 0, right at the very, very bottom, right? I can find the minimum of that parabola. And then over here, the slope would be positive, all right? Every one of those slopes you find from the derivative. Okay, so I just wanted you to have a visual. I'm gonna do the rest on paper. Okay, so now that I'm on paper, I'm only gonna be doing one example. So I hope you really, really get it. And I am available for office hours so I can answer your questions. Okay, so I've given you this equation. This is a parabola. I'm not going to draw the parabola, but you know that it's a parabola, all right? And I want to find the equation of the line tangent to it at this particular x value. Okay, now, if I'm finding the equation of a line, I need two different things. I need a slope, right? And I need an ordered pair. I need an x and a y. Okay, so let's start with finding the slope. The slope to this parabola is found with the derivative. So the derivative, if I use the shortcut, is 6x plus 5. Okay, now this is the slope anywhere. And I know it seems really, really weird that that's the slope anywhere, but it depends on what particular point value you put in there. So we want to find the equation when x equals 1. So I'm going to evaluate, the derivative at 1. So 6 times 1 plus 5 is 11. This is the slope. This is the slope that I'm going to be using in just a second. All right, so now the second thing that we need is an ordered pair. So I can figure out the ordered pair not from the derivative, but from the original function. If I evaluate the original function at 1, 3 times 1 squared plus 5 times 1 minus 2, what is that? 3 plus, that's 8 minus is 6. So this is what's called the point of tangency. When I plugged in 1, 6 came out, there is the ordered pair. And that's all that I need to write the equation of the line tangent. I need a slope and I need an ordered pair. So here we go. I'm going to do point slope form. Y minus y is equal to m times x minus x. And when I move that 6 to the other side, this is the equation of the line tangent to this parabola at x equals 1. All right, and you can plug this into Desmos. You can check it out. You'll see a parabola when you plug this in. You'll see a line when you plug this in. These two will touch at this ordered pair. Give it a try. Let me know if you have questions.